this video on electric charges and fields, covering the fundamentals of electromagnetism and electrostatics. Electric charges come in two types, positive and negative. Protons carry a positive charge, while electrons carry a negative charge. Rubbing materials, like glass with silk or a plastic rod with fur, demonstrates how charges can be transferred, resulting in a net positive or negative charge. Electric charge has basic properties. Additivity means the total charge is the algebraic sum of all point charges. Quantization means all observable charges are integral multiples of the fundamental unit of charge. Conservation ensures that total electric charge remains constant in an isolated system. Materials are classified as conductors or insulators based on their atomic structure. Conductors, like copper and silver, have loosely bound electrons that allow current to flow easily. Insulators, such as rubber and plastic, have tightly bound electrons that resist charge flow. Coulomb's law describes the electrostatic force between two stationary point charges. This force is directly proportional to the product of their magnitudes and inversely proportional to the square of the distance between them. This is often referred to as the inverse square law. Electric field lines are imaginary curves indicating the direction of the net field vector. Lines start at positive charges and end at negative charges. Importantly, field lines never cross, and electrostatic field lines do not form closed, continuous loops. An electric dipole is a pair of equal and opposite charges separated by a distance. Electric flux measures the total number of electric field lines crossing a given area. Flux bridges the gap between the electric field of an object and the total charge contained within it. Gauss's law states that the total electric flux passing out of a closed surface is equal to the total enclosed charge divided by the permittivity of free space. This law is a powerful tool for calculating electric fields in highly symmetric systems. Gauss's law is applied to calculate electric fields for various charge distributions, including an infinite line charge, an infinite plane sheet, and a thin spherical shell. The principle of superposition is crucial when multiple point charges are present. It states that the total electrostatic force on a charge is the vector sum of the individual forces exerted by all other surrounding charges. The force between any two charges remains unaffected by others. Comparing electrostatics and gravitation, electrostatic force can be attractive or repulsive and is highly medium dependent. Gravitational force is exclusively attractive and completely independent of the medium. Thank you for your engagement and attention to the fundamentals of electromagnetism.